Okay, so let's look at this problem. The problem, oh, I do apologize, it's gone off the side there. I can edit that another time. In these circumstances, we're going to look at this. I've judged that part that's cut off is not too much of a problem. You've been given a graph. The graph gives you an x and a y-axis. It does not state what those x and y-axes represent. For now, you're given a graph that looks like this, tan-esque or inverse sine-esque. From A to point B with the origin stated. And then if you look at the question, you can see exactly what's manifested. The diagram shows a curve y equals 8 sine to the power minus 1 x minus 3 over 2. And there are 2 points, A minus 4 pi and B 4 pi. One thing to be aware of is that these coordinates are often x comma y, especially if it is Cartesian. That is not specifically stated in the question, but let's be honest, that is what was stated. That's perhaps what can be described as obvious. So here we have the x is A, so that is to say where you are along the x-axis. If I was to do something a little bit thinner, let's say where I am along the x-axis, that could be described as the little a. That's little a there. So for example, I could say that that position there is little a. And where I am along the x-axis for the top one there, this is a negative value of y, so I'm assuming that is our a, and this is a negative value. It says the endpoints a and b in the curve, and so although that might be missed off, assume for now that is what is meaning. This point b, this is the x. The x goes before the y, so the x, and so this is our little b here. And so next stage is, well, then the y has also been stated. The y is minus 4 pi. So let's say that at that point here, this version there, I'm not going to be able to, I'll have to go back to LaTeX to change that, so to write in the 4 pi correctly. So I'm just going to write 4p is there. And remember that in these circumstances, is actually for that one, it is stated very clearly that that is meant to be a minus 4 p. So this is minus 4 pi, which is the equivalent of 3.14 if you're going to do three significant figures. Next is, therefore, this b has been stated again at the point b. So b is the x. What is the y? The y is 4 pi. So I'm going to write up here that this is 4 pi. So that's kind of this is kind of like what has been given. You should always break things down into what has been given. You've been given this equation that we're going to play with quite considerably. You've been told that you have a point A minus 4 pi, and I'm just making you very aware that this is representing x comma y, and that this is also representing x comma y. So it might be advantageous to apply that to the diagram straight away so we can know in more detail what's going on. Now, another thing to be aware of is the circumstances in here. This 8, what does this 8 represent? Well, if you are aware of transformations of graphs, well, for any function, what will happen is a number will enter into x. This is not the best of language. This is language just to aid in the description. I wouldn't call it mathematical at all. But a number enters into x. So, for example, let's say the number is 5. The number 5 is going to enter into x, like so. It is then going to you're going to take away 3 over 2 from it. Then it will go through the situation of being a value that goes through sine to the power minus 1, and then it will be multiplied by 8 before finally giving you a y value. So whatever this multiplied by 8 is actually going to cause an upward stretch in the positive side, because if it's a positive number that comes out, let's say it's positive 2 that comes out, it will be times by 8 to give you 16. So what happens then is when it should be 2, as a result, it will be multiplied up by 8. Right? And that's what that 8 is doing then. The 8 is causing an amplification. If you were talking about it in terms of physics, you'd say that this is capital A amplified by 8. Also, you can call it a vertical stretch. And so if it was a negative number that comes out of here, like minus 2, then you'd have the opposite. It would be minus 2 multiplied by 8. And so what you'd have, of course, is you'd have again a stretch of times by 8. So that's what that 8 is doing. So again, more information about what is given right at the beginning. That's what's happening there. Next thing, what is this minus 3 over 2 doing? What is this minus 3 over 2 doing? Well, this is shifting the curve. It's shifting the curve when normally a value of x will come in, and then that x will go through sine to the power minus 1 and then multiplied by 8 to produce a y value. Now, when that value of x comes in, you're going to take away 3 over 2 from it. So it's not going to read x. Let's say this, imagine this is a person who reads what's coming in here. Imagine this sine to the minus 1 is one of your friends, and he's reading what comes in here. And let's say a number comes in, let's say like 5 over 2 comes in here. 5 over 2 comes in here. And it's like, okay, they could have read 5 over 2, but because the minus 3 over 2 comes along, it's going to take away 3 over 2 from that 5 over 2. 5 over 2, take away 3 over 2 will be 2 over 2 or 1. And so instead it reads 1. So this is causing a shift in what is read. So it causes a shift on the x-axis, positive shift by 3 over 2 and to the right. And we can discuss that in more detail when discussing transformations, because it might be worth showing that in a much more step-by-step form. But notice that, just to notice in terms of functions, that's what happens. We don't need to know that kind of information to solve this problem, however. So if what I've done so far has not aided you in understanding and caused mild confusion, I do apologize, but we don't need to know all of that. What we do need to know for now is that we've been given two coordinates, x, y, there's our first coordinate, a minus 4 pi, and we've been giving b 4 pi, that is our second coordinate, and I've implemented those. It's worth knowing that that 8 is causing amplification, and it's worth knowing that that minus 3 over 2 has just caused a mild shift along the x-axis, but it's not vital. And so what we're going to do is we're going to utilize our understanding of trigonometry instead to solve this problem in the next video.